Attracting tomorrow. TDK.
TDKs, micropointer loads are so easy to design, we're going to go ahead and design them on the beach with TDK's new Power Strip application engineering board. Okay, here we are now in Oceanside, California. I've set up my demo along the beach here. I got my meter, the TDK Power Strip board with 6 modules in operation. We also have the dialog power sequencers here to the right, and then the Faraday I2C programming dongle. What we're going to do here today is to show how easy it is to show power designs for various FPGAs. The first one I'm going to show is the Zinc 7 FPGA from Xilinx. You can see the kit, and as I had promised, we're actually programming it on the beach. So easy to program, we can actually do it on the beach. Now the kit itself, as you can see here, actually comes with some instructions. And what I want to show you is the various setup here to quickly set up the system on your Power Strip board for the dongle, the connecting to the board, and the overall setup. Plus also the addresses for the various power modules that are on this board. What we're going to do first is we're going to quickly look at the board to do some power designs for various FPGAs. Here I've listed the Xilinx series for Spartan 7, Arctic 7, and Zinc 7, and Zinc Ultrascale. On the back we have others as well for Altera Cyclone, Aria 10, IMX.8, Microsemi Polifier, the NXP QRQ, and the Cavium Octeon, and the Marvel Armada. So what we're going to do today is we're going to focus on the Zinc 7 design and demonstrate the power on the board. Okay, here we are. We have actually powered up the board. We have it configured, the Power Strip board configured in the Xilinx Zinc 7 configuration. We're actually looking at output 1. This is the core voltage of the VCC IT rail. You can see it coming in at 0.998 volts. And then as we go from rail to rail, from output voltage 1 to 2 and to 3, we can actually see the other voltages of the Zinc Ultrascale very quickly. Let me demonstrate. The VCC aux rail should be coming in at 1.8 volts. There's 1.8 volts, 1.805. As you can see here on the screen, 1.805. And we can also take a look at the PSDDR rails, the bus rails at output 4. Let's take a look at output 4. That's the ground rail lead, and then the VCC lead coming in at 1.2 volts, as you can see there. So quite easy, just power up the board and you can actually do a quick demonstration of various FPGAs on these power modules using the TDK Power Strip demo board for field application engineers.
Attracting tomorrow. TDK.